Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. F.A.S. and in this video, I'm going to talk about the topic of radar range. Okay, so in the radar system, the way that how do we able to calculate the distance between the radar transmitter and receiver with the object that we want to detect, right? For this example, we use a quasi monostatic radar, which is we have a transmitter and receiver separated but located at the same location. And when the transmitter transmit the pulse signal to the distance of r towards the object, okay, this is the object that we want to detect, and the signal will be reflected back to the receiver, right? So we have a power of the transmit power, right, PT, from the transmitter, and the signal will be will be going through a amplifier that we have a certain gain at the antenna. So we call it as a transmit antenna gain, and then the signal will go through the object, right? And then on the object we have sigma. The sigma is the radar cross section, which is generally we talk about how much of the signal is being reflected from the object. So if the object is large, so we have higher amount of lambda. So the object is small, so the sigma will be much smaller, right? When the signal reflected from the object, then it will going through the receive antenna, and this antenna have a GR, which is the receive antenna gain, and the signal will go, and then we can get the value of the uh, receive power, right? So generally we can look at the process on how this signal is going from the transmitter to the object, and then from the object to the receiver, right? So from this situation, so how do we calculate the amount that this is something that we would like to know, right? From the process is how much is the range. How do we calculate this? We can get it on based on how much is the receive power that we can get from the receiver, right? So we have this equation. So we have the amount of receive power PR. This is equal with the PT times GT times sigma times AER, right? So AER is the value of effective aperture area of the receive antenna. So AER generally roughly we can say it as the efficiency of the receive antenna, right? So we have the values between 0 to 1 lah, so 0. Typically maybe around 0.35 above lah, 0.5, 0.6, right? So the higher amount of AR, meaning that we have better PR lah, so the more signal we can receive. So over P 4 lambda r square, right? This is the surface area of a sphere powered by 2, right? And then we can arrange this equation into this one. If you notice, it introduced with the uh, lambda, right? So this is how we get lambda. We get from this equation, right? So this is the speed of light, which is constant, equals to frequency times lambda, right? Okay, sorry, basically the lambda we can get from here actually. Okay, not this one, not this one, right? So basically, there's an equation that we can change the AER. Indeed, this one is actually in the case if the antenna that we have is isotropic antenna. So we can consider this is a AER, right? So you can change the value of AER here. Basically, you can change like this. PR equal to PT GT sigma, and AR is equal to lambda square over 4 pi. So lambda square over 4 pi, and then we have 4 pi r square, right? So we have 4 pi. We can separate this 4 pi first square, and then we can take out this r square over here, so we can have r to the power of 4, right? And so if you rearrange this equation, so we can get pt gt sigma lambda square over 4 pi to the power of 3 and r4, right? So this is how they get this equation, right? So it's simple, right? So basically, you can use either of this equation, but this one is much more generalized, meaning that if the question is giving the value of AER, the specific value AER, so you can use this equation. But if the question doesn't specify what kind of antenna, so you can assume by using the value of lambda. Lambda is the wavelength of the signal that we are using. Okay. So in the next part, we like to try out this equation in one situation. Okay. So for example, we have a situation that we want to detect some object here, right? Subject. So this object could be any of these things on this list. So for example, we want to try, okay, we want to try detecting a small combat aircraft, right? This one. So the sigma of this object is about 2 to 3 meters square. So let's say we take a value of 2, okay? 2 meter square, right? So sigma is 2 meters square. So assuming the transmit power is 10 watt, uh, transmit and receive gain is 1 right? It's basically it doesn't uh, increase the value of transmit power, but if you put these values, right? So assuming these values, and AER is given 0.5, right? So so how do we find out the relationship between uh, receive power and the range? So if you can get this equation, meaning that any value of receive power that you can get, we can know the distance between the radar and the object, right? So like we can try this out. So let's say, and we're using this equation, right? The first one, this first equation, we try PR equals to, okay, PT is 10 watt, right? PT is 10 watt. So GT is 1, and we have PT GT, right? Okay. So GR. For the first equation, we didn't have any GR, right? So we can exclude that. So since we're giving AER, so we can check for sigma. So sigma is 2. The value is 2. And then AER is 0.5, right? Over 4 pi r squared. Over 4 pi r square square, right? So please be careful with this equation, right? So if you stumble upon this, if you want to calculate, then you have to separate between the pi and the r square. So basically we can, if you arrange this equation, so you can get something like this, right? PR equals to 10 20 20 times 0.5, so it's 10 over 4 pi squared. Okay, so we have 4 pi squared and then r to the power of 4. Right, so we can get this relationship between uh, the receive power and the range. So how we want to know what is the distance between transmit and receive? So we can rearrange this equation and we can get r will equals to PR over PR times 4 pi squared over 10, and we have I write it like this, okay, 1 over 4 to the power of 1 over 4. So this is the same with the uh, punca kuasa lah, punca kuasa 4, right? Okay, root of 4, power of 4. So you can get this equation. So in your system, you can use this equation to estimate the range, the distance between your radar and your object using this equation. Okay, all right. So I think that's all for in this video. Uh, we will meet again in the next one. I will leave you with some exercise for you to do in this with this video. All right, all the best. See you next time. Assalamualaikum. Goodbye.